rectangle in the desk. See what I'm saying? And then we can make a whole bunch of them and make them really, really fast. But also, it kind of kills me when people are like, well, when is math used in real life? Well, if you enjoy any of the products that you have in front of you, anything that was ever created in a factory by a computer, or if you enjoy using your cell phone, that's all calculus, is how your cell phone works. But even just like the lines in a game on your thing, anytime you see a straight line on anything that is technology, not just a calculator, but anything that's like a cell phone, is always this. Which means that there's somebody out there who creates a program, right, for the first time on your cell phone. They're the first person who created whatever dumb game that you want to play on your computer when you're like spending extra time, right? In that game, that person made a whole bunch of money for coding that original game and for coding pieces of it. And it wasn't just one person, it was a team of people who made a whole bunch of money doing that. So if you're like, this little kind of like minutia stuff and doing this math like this is kind of my jam, cool, get ready to make some money, because you will. If it's not your jam, that's okay. You're still going to have to understand how to do taxes and pay tips and stuff like that. But you will not have to do this, but you will use products that people do this all the time on. Okay. So that goes through this point. Now what should we do? Yep. So plug that point in. For x and y. Over here, my step 1 was y equals, what is the opposite reciprocal of negative 3/2? Positive 2/3. So it goes from negative to positive in this case, and it flips. This is just the example that I just did, right? Yeah. So positive 2/3, x plus b. Remember that perpendicular lines do not necessarily have the same y-intercept. So this plus 6, we're not even using that. Number 2, I'm filling in x and y. This is x, this is y. Negative 2 equals 2/3 times 1 plus b. I'm going to make that a 1 over 1. What's next? You know this. Solve for b. That's negative 2 equals, let's see, this would still be 2/3 plus b. And then we're going to subtract 2/3 from both sides, which means that b equals, what's negative 2 minus another 2/3? Negative 2 and 2/3. You could also, if you wanted to create a common denominator, you could call that negative 8/3 if you want to, but I'm fine with a mixed number like that. Final step? Rewrite the equation. Okay, now that's 2/3 x minus 2 and 2/3. Are these notes feeling a little repetitive at this point, right? Doesn't it feel like we're doing the same thing? Mm-hmm. Now, that can be frustrating. Also, we're not going to be doing any more of these this chapter. So it's not like this chapter, every section, there's 2 of these. That's the end, okay? We've got other things we're doing this chapter, but it is not going to look like this. I will be doing stuff like that later in different chapters, but not now. The reason why I really wanted my notes to look like this is because a lot of these problems are so similar that it's easy to mix them up in your head, like what the steps are, so it's nice to have these concrete examples. How are you guys feeling about this so far? Great, let's do an example that you can win a prize with your partner on. All right, write the equation of a line. Perpendicular to y equals x plus 4. That goes through 3, negative 2. Before you start working on this, Well, let you finish writing first. All right, let me make a quick point. What is the slope on this one? 1. But since you're flipping it and adding a negative if it's positive or positive if it's negative, maybe it'd be easier to think about it as 1/1. Okay, anytime you're doing a perpendicular line and something is not a fraction, make it into a fraction. It might be easier to understand. Okay? You want the answer? The answer is going to be y equals negative 1x plus 1. All right, talk to your partner. Go.
How you doing?
What do you think of the consumer math so far?
I think it's gonna be good.
Yeah. A little easy at the beginning, but the conversation should get good. Like today, I was like, "What's FICA?" and not a single person knew. So like, we're gonna start getting into that kind of stuff. Are you happy you're in it? Yeah. You're making a weird face. Or were the other options horrible?
So this we actually learned stuff and that will help us like in the future.
No. I'm gonna go ahead and pretend that you're not insulting the other class I teach.
Not this class, but
Some other ones?
yeah.
Okay.
Like ninth grade orientation, I don't really get.
That's it. That taught us much.
Are we all done? Okay. Want a little bit more time? Did this help you understand why it's an opposite reciprocal? Should have used different colors, shouldn't I? All right, next hour I'll use different colors. I started especially when I was like, man, what are we doing? Okay, next hour I'll get better. You have the unfortunate experience of being my first class every day.
Not very
Okay. Talk to your partner about whether you'd like to come up here. Hands up. 1, 2, 3. Really? Surprising. Not in the mood today? 3.
Do I need to talk to my computer?
Yes, please. Okay.
Alright, so,
Be polite now.
you're gonna flip, and you get -1 as your slope, and then you would end up plugging in your points. -2 equals -1 times 3 plus b. And then multiply and solve. So -2 equals -3 plus b, and then add 3 on both sides, and you get b equals 1. And then rewrite y equals -1x plus 1.
Perfect. Easy peasy.
Number 3.
Okay. The homework is still what it was yesterday. It is due on Monday. The homework was page 304, correct?
Yes.
26 through 29, and everybody realizes you have to do the parallel equation and the perpendicular equation. So they're